Factoring today, we're going to talk about how to use factoring to solve a polynomial, and then we're going to go backwards a little bit and essentially put it on its head. If we start with our roots, how are we going to come up with a quadratic that has those as our solutions? So first up, 6b to the fourth minus 19b cubed minus 20b squared. First thing you always look for in any factoring process, GCF. Now these don't share a numerical GCF, but they do share a b squared. So I'm pulling the b squared out first, leaving us with 6b squared minus 19b minus 20, still equals 0. You'll notice all we do when we pull something out, essentially if you go into a parenthesis, you multiply. So if you come out of a parenthesis, you divide. And that's how we got our trinomial left. Now, we've been working more and more on our guess and check method. Once you get good at this, you should be able to find some patterns and do this pretty quickly. We'll go a little slower this time through it, but you should be eventually doing it pretty quick. First thing I notice is the back sign's negative, so I know I have 1 and 1. 1 positive, 1 negative. I know my front terms have to be multiples of 6b squared, and I know my back terms need to be multiples of 20, which could be 5, 4, 10, 2, or 21. Now, I also know that my middle term's negative, meaning when I do my multiplication, my negative product has to be larger than my positive product. This is going to help us when we start guessing and checking things, because I'm not even going to try a combination unless the negative product will win out. So let's just go straight with 3b and 2b. Let's try this first, okay? I want to have the larger numbers be negative, so I'm going to go with 5 and 4. Now we're just going to try this one first. I get a negative 15 and a positive 8. So I don't have enough negative. I need something larger, okay? My next guess would be, okay, let's try 10 and 2. So the first products I tried were too small. Now I get negative 30 and positive 4. Okay, I'm getting closer, but I'm still at negative 19. So 3 and 2 is not working. So try another one. We're going to go with 6 and 1. Now I'm going to put the 6 in this first slot because that way the 6 will produce my negative product. That's what I want. I want the larger product to be negative. So let's go back to our originals. 5 and 4. Okay, negative 30, positive 4. Too big of a negative product there. Let's maybe switch these and maybe we'll get a little bit closer. Negative 24, positive 5. Bingo, got it. Now that you eventually will start doing in your head. I wanted to at least explain the thought process, but that's essentially my guess and check method of how I start running combinations and scenarios until I arrive at the actual products that will give me my desired middle term. My fronts will multiply to the front, my backs will multiply to the back. Okay, we have fully factored this polynomial. Now it's time to solve. Well, keep in mind, what's really going on here? Multiplication. We're multiplying 3 things by each other, and the end result is 0. Well, what do you have to multiply by to get 0? 0. Now, do they all have to be 0 in order for it to equal 0? No. As long as one of them is 0, the rest of it will become a true statement. So, what I do is, I essentially think, well, if b squared equals 0, it would be a true statement. But if 6b plus 5 equals 0, well, it'll still be a true statement. And if b minus 4 equals 0, it'll create a true statement. So understand, each of these are scenarios that will produce a true statement. So any scenario that can produce a true statement is a possible, not possible, an actual root or a solution. So this one's pretty nice. Add the 4, b equals 4. Here I subtract the 5. 6b equals negative 5. Divide by 6, so b equals negative 5/6. Lastly, now you can probably guess this one. What do you have to square in order to get 0? 0. Now keep in mind, because this is b squared, it actually contains 2 roots there. But those are my solutions for this polynomial. And that's the same thing you'll do in your process. Factor, set each of your quantities equal to 0. If they can possess a true, if they can produce a true statement, then they are an actual solution. Now this one we're going to do the opposite. They're telling me what works. I want to know what quadratic do they come from. So what I do is literally the opposite. This is what x equals. I'm going to write it out. So x equals -7 and x equals 2/5. Now these came from a scenario that was set equal to 0. So that's exactly what I want to do right now. I want to set these equal to 0. So essentially I am unsolving. This was the quantity that produced the solution -7. This one you got to do a little more work. Multiply both sides by 5. And again, what am I doing? I am getting these equations equal to 0. Subtract the 2. So this quantity and this quantity produced my solution. Where do these quantities come from? Those are the factors. Notice, before we set things equal to 0, they came from our factored form. So if I continue the reverse pattern, that means I had x plus 7 times 5x minus 2. It truly is the exact same process, just inverted. Multiply it out, I get a 5x squared. Positive 35x with a negative 2x gives me a positive 33x. And lastly, negative 14. And that is the quadratic that produced those roots. Quick tutorial on guess and check factoring, solving using factoring, and how to produce the quadratic that gave us those certain roots. Now again, this will work if you have more. If it goes higher than a quadratic, if you get a third root or fourth root, use the same process. Get your root to be equal to 0 by finding the quantity that produced it, and then multiply all your quantities together to arrive at your original polynomial. Hopefully this helps. Enjoy.